Hi all, welcome to the DC-SCM base specification and design details session. I'm Priya Raghu, a hardware engineer at Microsoft Cloud Hardware Infrastructure Division. This is a joint session by me and Book Kao, who is the engineering director at Winwin. I will be going over some main elements of the DC-SCM specification, and Book will be going over some design considerations with respect to an SCM that they have been working on. So here's the agenda at a high level. We'll be going over some acronyms which we frequently use in the spec, some key requirements, supported form factors of the SCM, key interfaces of the SCM module, an example block diagram that puts together all the interfaces, and some next steps to follow up on. Here are the acronyms. DC-SCM refers to the Data Center Security and Control Module. DC-SCI is the Data Center Security and Control Interface. It's the standardized connector interface of the SCM module. HPM, which is basically the motherboard or the host processing module managed by the DC-SCM. The HPM FPGA is basically the programmable logic device on the HPM, typically used for power and reset control, with the added function of serializing and deserializing the GPIOs between the HPM and the BMC. The SCM CPLD is a programmable logic device on the SCM which is responsible for serializing and deserializing the GPIOs between the HPM and the SCM. It also performs some management functions on the SCM. So going over some key requirements, the spec aims to be CPU as well as BMC vendor agnostic. It is scalable across multiple sockets as well as GPU and AI based systems. The signals across the connector interface are standardized. The form factors supported are standardized. It supports security and management functions. It attempts to be future-proof using reserved signals as well as by allowing for future expansion of signals via the serial GPIO interface. There are three supported form factors. The horizontal form factor, which can either be front or rear, vertical form factor, and internal form factor. All the form factors use the industry standard 168-pin 4C plus connector. On the right, we see a picture of a horizontal form factor SCM. It is a 120 mm by 90 mm module. It is coplanar to the HPM. It is derived from the OCP NIC 3.0 but is wider and longer than an OCP NIC, making it mechanically incompatible with an OCP NIC form factor. It is also electrically incompatible with the OCP NIC. So this shows a horizontal form factor SCM in a typical 1U server. You can see some of the front accessible ports and LEDs on the SCM here. So the key interfaces via the DC-SCI can be broadly classified into three subsystems: the power subsystem, server status and control subsystem, and I/O subsystem. Moving to the power subsystem, so the 12-volt aux from the power supply is the source of power for the SCM. The spec defines three sequencing signals in order to ensure an orderly turn on of the system and to avoid unpredictable system behaviors. The signals are standby enable, standby ready, and standby reset signal. The spec also defines two present signals on the DC-SCI, the present 0 and present 1. The SCM power can be enabled based on these present signals. So the figure below shows a typical power subsystem block diagram with an SCM. The 12-volt aux from the power supply is turned on to the SCM via this eFuse, which is enabled by these present signals. The eFuse is recommended in order to protect against overcurrent conditions. The standby VRs are the first to turn on, after which the SCM enables the HPM standby VRs via this HPM standby enable signal. Once the HPM standby VRs are good, this HPM standby ready signal is input back to the SCM, which in turn releases the HPM standby reset signal to the HPM. The spec does specify a max power of 28 watts for the SCM after derating, and finally the SCM is not intended to be hot swappable. Moving on to the server status and control subsystem. So there are buses wherein the HPM is the master, including the eSPI and LPC bus used in some architectures, or I2C bus used in some other architectures. There are also buses where the SCM or the BMC is the master, like I2C, I3C used typically for DIMMs on HPM, as well as QSPI typically between the BMC and the HPM FPGA. We also support the serial GPIO interface between the SCM CPLD and the HPM FPGA. Moving on to the serial GPIO interface, the signaling involves 4 signals, which are the clock, load or select line, and data in and data out signals. The target frequency of the clock is intended to be 25 MHz or higher. We also support a high latency and a low latency interface. The latency being determined by the number of GPIOs which are serialized on these buses. High latency signals include CPU alerts, VR alerts, power status and I2C alerts, as well as some MUX selects and SCM status and control signals. Some of the low latency signals include power throttle signal or PSU alert type of signals, wherein a quick response may be desired in the system. Moving to the management and telemetry signals, we support a total of 11 I2C buses and 4 I3C buses on the DCSCI. These buses are fully dedicated to the HPM and not shared with the SCM. We recommend that the fan control be done through an I2C based fan controller on the HPM in order to avoid cabling to the SCM. We also support PECI as a management bus for architectures that use it. For debug, we support several interfaces like JTAG, USB, and UART. Other IOs via DCSCI include a PCIe by 1 interface, typically used for video or firmware update, the network controlled sideband interface. The spec provides a detailed timing considerations for this, host boot interface like SPI or QSPI, as well as miscellaneous GPIOs like root of trust, reset controls, debug IOs, interrupts, as well as some power supply related signals. Finally, putting all of these interfaces we talked about together in a block diagram, looking at some of the key components, we see there's the BMC and the associated memory. We have the root of trust, as well as the BMC and the BIOS flashes, the SCM CPLD, the trusted platform module, and the front panel with the USB, mini DisplayPort, and RJ45 interfaces. Again, the spec goes into a lot more detail into all of these interfaces. Next steps. We would love for you to get involved by joining the DCSCM subgroup and signing up for the mailing list shown below. Please review the latest SCM specification up on the OCP website shown here and provide your valuable feedback. Thank you for joining this session today. I'll now hand it over to Book.
Hello everyone, this is Booker from Winwin. I'm a EE. I work with Microsoft Gen 9 project. SCM will implement in Microsoft Gen 9 project. This is SCM and Microsoft Gen 9. SCM will place in middle area. You can plug it in front side. About the SCM placement, You can see all the firmware parts are in SCM board. BNC parts, bridge parts, and CPLD, TPM. The special part is Cerberus. Cerberus is Microsoft designed security part. You can get SPI bus. No Cerberus SCM cannot put up, and no SCM CPU board cannot put up. SCM block diagram, we define a SCI interface to let everyone follow it, and you can, based on our pin define, to design your SCM board and design your base board. And if you follow the SCI interface, you don't need to design the BNC anymore. Pin define is limited, so we use the GPIO pin to transfer the low speed GPIO from BNC to CPU base board, such as thermal triplet processor pin. What we will consider as the SCM design, we consider size, cost, serviceability, open firmware, and the design experience. How about the size and cost? If we design SCM, we can reduce around 10% PCB cost. This is because high-speed PCB material is very expensive. And how to avoid SCM and OCP NIC card use the same connector? How to avoid we plug SCM in OCP NIC slot, and how to avoid we plug NIC card to SCM slot? We design a different board size as this one. When SCM plug in OCP NIC card slot, SCM card is more wider than OCP NIC card, so you cannot plug it. When OCP NIC card plug in SCM slot, SCM card is longer than OCP card, so OCP NIC cannot touch to SCM connect. This is our fail-safe design. About open firmware, we can use the different BNC chips such as SPID and Noventa, and we can design the open BNC and the customization BNC. And we don't need to test the BNC board if we change the motherboard. If Microsoft agree, we can sell you the SCM board and give you the customization BNC firmware, so you don't need to implement BNC anymore. Winwin has the AMD project experience which designed the SCM board. We meet many issues such as SPI and other issues, so we have experience in SCM board. So I have confidence SCM can meet its spec. So this is what we consider the SCM interface and the connect and our experience. This is SCM. So any question, you can send the email to below link. Thanks.
Winwin, your best choice for workload optimization and TCO.
Hi everybody, please let me know if you have any questions.
Muted.
Thank you for taking the time to attend today's session. Please feel free to ask me any questions if you have over the chat window. So the question was, do we have a firmware spec? Not yet. We will be enabling OpenBMC firmware for this platform. So when you mean handouts, I assume you mean the specification. So it's in the works. We are actually at revision 0.6 of the specification. So hopefully soon we should be able to release that to the OCP community. The links are actually available in the presentation here. So when you say timeline, do you mean timeline for releasing it to OCP, the spec to OCP, or oh, so your question was about when is the firmware spec available? So I'm not sure when they're going to be releasing a separate firmware spec. So the goal of the DCSCM is actually to have a common hardware, a common mechanical and electrical interface, and the software part of it is actually configurable. It can be different across different DCSCM providers, DCSCM designers. For a specific firmware spec, as is, we don't have a fixed timeline as to when it's going to be available, but I can take that to our partners and let you know. So Microsoft has been working with Winwin in designing a proof of concept for the DCSCM. The question was, where can I find a sample of DCSCM? And Microsoft has been working with Winwin in developing a proof of concept for a DCSCM. We just recently received the first modules, and hopefully we should make that available. If you're interested. So please shoot me an email, and I can give you more details. So this presentation, when you say handouts, I mean this presentation. This presentation, I believe, should be available on demand once this live one ends. Timeline for OpenBMC support. So that is also a work in progress right now. We're still in the proof of concept phase, but we are in the process of the BMC firmware bring up and also interface to the HPM. So I don't have a fixed timeline for you right now, but I should be able to get that to you if you send me an email. If this is 0.6, I presume there isn't any platform that can be bought today with a DCSCM. No, there isn't a platform yet with a DCSCM. It is still in development, and we are in the proof of concept phase. And the goal is for us to enable the DCSCM on the next generation of dual socket servers here at Microsoft. Yes, so the question was, does DCSCM leverage include Cerberus? Yes, the DCSCM includes the Cerberus version 1.0 module. So the question is Cerberus integral part of DCSCM, or is it a pluggable module? So right now, the Cerberus is a pluggable module on the DCSCM, but in future, we are also looking at integrating the Cerberus onto the DCSCM as a chip which is down on the DCSCM essentially. Does it also provide PFR as in many other solutions? So we did look at DCSCM if it could support PFR, and we believe that the specification would support the PFR if somebody decides to implement PFR as their security option. Microsoft is not using PFR because we enable our DCSCMs with Cerberus, but we believe there is no reason that you shouldn't be able to support PFR if you want to. Interface BMC Cerberus is standardized by the DCSCM spec. Yes, the BMC to Cerberus spec is, well, so there are some root of trust related signals which go through the DCSCI, which is the interface to the motherboard. So those root of trust signals are standardized. Now, if there are some specific signals on the SCM itself to your individual root of trust, which could be Cerberus, or which could be Titan, or which could be something else, so that would be specific to the DCSCM design. So the goal of the DCSCM specification is to standardize the form factor and the electrical interface itself, while giving the designer the flexibility to design within that framework. So if you have certain root of trust signals which are very specific to your design internal to the SCM itself, then you're free to implement that. But we do standardize the root of trust signals that go through the DCSCI interface to the motherboard. Does DCSCM module perform measurement and authentication of all devices attached to a host? Yes, the goal of the security on the DCSCM is to enable authentication of all programmable devices on the host. So I'm not sure what you mean by measurement, if you can explain that. Yes. Yes, that's good. Measurement means validation that device firmware has not been compromised. Yes, so I'm not really a security expert, but yes, we do have the full functionality of the the Microsoft Cerberus or the Google Titan or any of the other security solution that you may use. We would fully support that on the DCSCM. I think Paul's question is about root of trust functions on the SCM module. Yes, I think I just answered that, essentially that all the ROT root of trust functions are available on the DCSCM. Does it utilize measurement and authentication work being done in any standard groups? So I'm not in the loop of the authentication and measurement works in the standard groups that you're referring to, but this is being reviewed. The DCSCM spec itself is being reviewed within Microsoft by the security team. And we're incorporating their inputs in it as well. So I hope that they would bring to the table any requirements. But if you have specific questions, please feel free to shoot me an email. Does the flash on the SCM card include firmware of other devices on the board except BIOS and BMC firmware? So the flashes on the SCM only include the BIOS and BMC firmware, and we do also have a CPLD on the SCM, which is the SCM CPLD, and it does include firmware for that as well. And apart from that, we don't have any other programmable devices. There is a Fru ID PROM associated with that SCM as well. Okay, move to questions in the questions and answer tab. When will handouts be available? So I answered that. Are there systems with the DCSCI interface available for purchase? I think I answered that as well. So but I think there were a couple of questions about handouts. I think you're referring to this presentation. It is available on demand. And I'm not sure whether all these presentations can be downloaded as well. You can check with the OCP committee here. Does DCSCM perform fan control of the server fans, or is it a pass-through of the signals? So we recommend that fan control be performed through an I2C based fan controller on the motherboard, and the DCSCI does not include the fan PWM and TAC signals on the connector interface. I think we have one more minute. So thank you for attending the presentation today. And the presentation itself has links to the OCP subgroup website. We hope we should be able to release the OCP revision 0.6 spec out on that site pretty soon here. So please review the spec, and we welcome your feedback, and definitely welcome your request to include any features or anything specific you would like to make clear in the spec as well.